The action of a controller needs to be defined, and that is whether it is either going to be direct acting or reverse acting. This is a once-off type of setting that you need to make, and it's no different to the auto or the manual of a controller or the P, I, and D settings, but this will just get done initially when the controller is set up for the first time. The way that it works is that you decide on the type of controller, and that is going to decide on the action. In the case of a direct acting controller, if the process variable was to go more positive or larger than the set point, then the output is going to go in the positive direction. In other words, your output would move away, for example, from 4 milliamps towards 20 milliamps if you're dealing with a 4 to 20 milliamp signal. The reverse acting controller or the indirect controller is going to be just the opposite. In this case, if the process variable was to go bigger than the set point, then the output is going to go in the opposite direction. If you're looking at a 4 to 20 milliamp signal, then the output is going to move away from the 20 milliamps down to the 4 milliamp section. The important aspect is to get your selection spot on. And what we're typically going to do is that the action of the controller is always going to be opposite to what happens in the process when you were to go and change a signal to the final control element. Let's simplify this. If you were to have a control valve feeding into a tank, and let's say that we want to control the level of that tank, then the first thing that you're going to do is you would say to yourself, if I give the valve a bigger signal, how is the process going to be affected? Now let's typically go and say that this is going to be an air to open, spring to close valve. It's a single acting valve. In this case, if I was to give it a bigger signal, my level would increase. So you can see that if you look at the two arrows, when the one arrow goes up, the other arrow goes up. That means that there's a direct relationship between those two, and my controller must be opposite. In this case, my controller must be reverse acting. Right, and one can actually go and test this. Let's go and say that I have a set point of 70%. That's going to be my set point. And if the process variable was to go up to 90%, because it's a reverse acting controller, my signal must get smaller. And if this signal was to get smaller, the control valve is going to close. So it makes absolute sense. And so you can go and use the same method of thinking for any process that you possibly are going to have in the plant. Let's go and have a look at the variable speed drive. Now, in this case, I've gone and drawn a tank with a variable speed drive at the bottom, and the variable speed drive is getting its signal from the controller. Maybe we can say that it's a 4 to 20 milliamp signal. Now, if the variable speed drive runs faster, it's going to take more liquid out of the tank. How do we decide on the action of the controller? Well, we go to the final control element, which is going to be my variable speed drive. If I was to give it a bigger signal, the variable speed drive would run faster, and as it runs faster, the level inside the tank is going to drop rapidly. So if you look at the two arrows, the one arrow is going up, the other arrow is going down. There's an indirect relationship between those two arrows, and my controller must be the opposite of that. And so in this case, the controller must be direct acting, and that's the way that you're going to work out the action of a controller.